classes. Y'all don't seem to be as much brought. If you've got questions for me, please just blurt them out. I can't always see the screen. I've got a student in a 4380 class. I think 3 times I asked him, please just ask your question. And every time he'd raise his hand, and it was only yesterday I'm doing something where I could see his hand raised. Actually, 2 generalized comments. Ethan, I found your book that you want to have, so I have that in my office if you ever want to come and get it.
Sweet.
And Erica, classic, Lucille Ball. I don't even know what it was about, but I liked it very much. I just saw it, and it was like all I could think is, I was wondering, what the heck is that? And it was like, so I liked it. I don't know what it was for, but I don't need to know what it's for, but I liked it. It was classic. Yeah, go ahead, Matt. That's what I was going to ask first. Anybody got any questions?
The semantic action vpush, to me, the way it's written, it almost looks like methods get added to the variable, or get added in vpush to the semantic action stack.
No, nothing that I remember. It's actually more like an iPush, except you can resolve the type basically immediately because you already know what it, because it's being defined. Does that make sense?
Yeah. The reason why I was a little confused is because when I looked at the enhanced grammar for production rule class_member_declaration, it always unambiguously executes vpush before running field declaration, which means that it runs a vpush regardless of whether the field declaration rule is a method or a variable. So should we actually just inside of vpush check to see if it's a method, and if so, not actually push it?
I would have to go look at it to remember exactly what you're talking about, because with respect to the other part you're talking about, honestly, I can't remember right now, because vpush I'm only aware of is being inside of a function. What you're describing is like it being a function, so it's
that's why I'm confused as well about the very thing. There's 2 vpushes in the grammar, one for class member declaration, and then one for the variable declaration part of the method body.
Yeah.
That way, instance variables of a class.
We can talk after it, and I'll see if it's just something that's written up wrong, or if I can explain it in more detail. Because I would go, from what I remember, it does, and maybe I'm only remembering one case, but that way I'm not just trying to do something right off the top of my head. Because
alrighty, and I do see an easy solution. In vpush, if the token is a method, don't actually push it.
Yeah. So see, that's why I'm trying to remember, where do I use vpush, and I really need to look at the grammar, so I'll really go, yeah, did I really use it in some place where there is a method? Because
class member declaration, but yeah, you can look at that later.
Okay, and like I say, remind me, we'll look at it. I do know I've got a couple of students who want to do syntax analysis right after class, but we can look at it.
It's not a high priority.
Okay. But yeah, do call me and let's talk about it, because maybe I want to make some kind of change. I don't think I've had a question on it, but like I say, even I got to get in. I try not to do stuff unless I know it right off the top of my head.
I think I can think of a change to factor the grammar, but I don't want to be so presumptuous as to say, hey, the grammar's wrong, I'm going to come and fix it for y'all. It's also an easy fix to implement in the semantic action vpush.
Yeah. But, hey, Ethan, did you want to add something?
Not necessarily to what Matt was saying, but it does have to do with syntax pass-offs.
Okay.
I've noticed a number of people come to me not really understanding what is needed before a pass-off. And so I just wanted to mention to everyone that you do need to have like one file that has all your test code in it, right? Not broken into multiple files and things like that. I've had a number of people who have had that, who have come to me.
So understand, all Ethan's asked you to do is don't bring multiple, stick it all in one so we can see all at once, because this is really what you need to be running is something altogether, and that's a cut and paste problem, not retype it. Just stick it all into one. Yeah.
Is this referring to a file that does not have any errors that we can get a full symbol table of?
Yeah, we will put errors in it ourselves, but yeah, because if you got something with errors, that's what we're going to give you at the end of the semester, but we'll put some selective errors into it. But it's so we can see what you have tested on to actually try and go, what syntax can you support? So again, it's in the PowerPoint slides and it's in the document that goes for it. It tells you all the types of things you should have, which is really everything, but it's kind of what Ethan's getting to, is it talks about there's no way you can do this without at least 3 classes. You ought to have pretty much everything that you can have 0 to many in. You ought to have a 0 case, you ought to have a 1 case, and you ought to have a many case. And the many case is many, many things. I've talked about how the expression should be done, and Ethan should be just like me. If you don't have that crazy, crazy long expression with everything in it, he should stop right there. I'm sure he does, but he should stop right there and go finish up your expression, because that's what you should be using over and over again. And people who've already come to me, like Matt and Dana and Matthias, did I finally do it right?
Yes.
Ah, great. Actually had these, even if they didn't have them at the beginning. And that's just a little selection of the things, but that's what you ought to come with. And yeah, but you should have already run everything and gone, it doesn't work, because we're not going to test everything. That is not what we're doing in a pass-off. We're going, it looks like you have something reasonable, and we'll run tests. We do an acceptance test at the end of the semester, which is where you get your grade, but we're just going, we'll give you some feedback and go, hey, if you don't have enough, keep doing more. But Ethan, you want to add some more?
No, that pretty much covers it.
And I guess that's good, because it sounds like some people have been trying to pass off with Ethan, because other than people I mentioned, I haven't had many people, except for I think the 3 or so that contacted me today to do it. So I'm glad to hear we got more people.
I was actually wondering if we could set up a meeting around 4.
Not with me, because I teach class at 4. So I'd go, you might be able to do it with Ethan, but I would say just contact us in Teams, and send a message. But no, I won't be able to do it at 4, because I've got a class today at 4.
Gotcha. Okay,
so
thank you.
I'll be available right after class to do with people, but I've got, like I said, it's 3 or 4 people that have contacted me right now and I really can't remember how many are doing syntax pass-offs. But I've got like 3 or 4 people that contact me. I've only called like 1 back, and I've called 2 back since I've been here.
Gotcha.
But do I have any other kind of questions? And even all these are valid questions, so they can be syntax, lexical, semantics, whatever questions you have. Because I'm going to just use this right here as kind of like a whiteboard, because I don't have technically a true whiteboard to write on. Might want to give me my pen. Come on. Finally. All righty. So no questions I can answer? All right. So we're going to start moving on. And the truth is, if you wonder why am I moving on now, I just finished semantics because I have to literally stay 1 phase in front of you. So if you will look, the due date for syntax is today. All right. So that really means if
hey, can you hear me now?
Schedule. Got what?
Hey, sorry, I had a question, but my mic wasn't working.
Oh, okay. Go for it.
Yeah, and it's just about starting semantic analysis, because it seems to me, I just want to make sure I'm understanding correctly, that we would reuse a lot of the code from the syntax analysis to start semantics.
Not just a lot. Basically, you're going to reuse all the code for syntax analysis, except for what you can think of putting stuff into the symbol table. So think of and you can relate it back to 4380. Remember, you reuse that same code that parsed out The assembly code, even though it's such a simpler problem, it is the same problem. In pass 1, we loaded the simple table. In pass 2, we used it and generated code. Okay?
Yeah.
We're really the exact same thing. It's just a much more complex problem. In pass 1, we're loading the simple table, but we have to do that syntax analysis. But technically, if you've done one pass on it, you are not really doing syntax analysis. You know it's fine. So what are you doing? You're using it to give you a context. So when you look things up for semantics, you know my variables are defined in the symbol table. I know I'm looking at expression, but I know the expression's fine. So just think of what you'll really do is you'll write ifs onto loading it into the symbol table, but that's really easy once you got it done to say, don't load if it's pass 2. Now, one way to do that, and I mean for everybody, you can put ifs on your calls, but you can put ifs inside the symbol table and still try and load it, and just don't load it if it's pass 2. So you don't actually have to change any of the code the way it looks in syntax analysis. If your symbol table knows don't load it, it just won't load it. And so you can just have all that code controlling it inside the symbol table. And
there is a problem with that though, because on pass 2 you will be defining temporary variables.
Right. But you just answered the question, Dana. It's temporary variables, and you know when you're loading the temporary variable.
That's correct.
So to some extent, you can deal with the temps by saying it, and people can write it differently, but you can think you don't pass an Alexum with a temp. And so you will know this has to be a temp because they don't have Alexum. Plus, you'll never do classes and functions. So it will just be variables, but you'll go with temps. Some people make a special function, but it literally can be use the same function that you use for adding local variables, because that's really what it is. Add it as a local variable, but if it doesn't have Alexum, it is a temp, and so you can go, oh, that shouldn't have the if around it. So yeah, you can do it all in there, because again, the symbol table knows everything. Because like I said, the problem is when you try and add all that code into syntax analysis and go, well, I'll treat all that out here, then you'll have that code all over the place. And if you figure out it's wrong, you may have to go all over the place and fix it a lot of places as opposed to one place, which makes it like an object.
Awesome.
Some more
Thank
questions? Okay. So, but again, yeah, so I'm standing in front of you. The thing is, you got to try and keep up. But what I'll tell you is, as long as you're getting well done with syntax analysis, you may not be done with it, but as long as you're not weeks behind, you are literally okay. But I have to stay to some extent in front of you, otherwise than the people who are staying up with the class, they're just sitting around twiddling their thumbs waiting to get done. And I know we got people who are keeping up with the class. All right, but we're going to have my intention is, it always is, but a general introduction to iCode, essentially intermediate code, because we're just going to get it going, and then I'll probably even stop. My guess is, unless we get lots of questions, it isn't my intention to go probably the entire class long, and it's basically give you kind of a general introduction so you can start seeing what's going on with it. I don't think I've gone in and released stuff for iCode yet, but I'll try and remember and go in and do that before the end of the day once I finish up talking with people. All right. So again, when I talk about iCode, that's just an abbreviation for intermediate code. All right. Now, there's something I need you to know before we start, and it is there's something you need to go back and add into your program that I didn't tell you about. And I didn't tell you not because I don't think you're smart, it's because information overload is almost part of this class. To some extent, it is because of the complexity of the project. Some of it, the complexity of this project was picked to make you deal with information overload, to get you ready to go out and go to work where problems are big and complex. And some are a lot bigger than this and a lot more complex. Some are bigger than this, and they're just the same amount of complexity. This has a whole lot of complexity, a whole lot of moving parts, if you want to think of in a small amount of space. All right. But there's something I didn't tell you. In fact, there's a couple of things I didn't tell you need to do, and I'm going to explain them, but they will make more sense now than if I tried to explain them before. It would have just slowed you down on what you're doing, and I want you to keep going. And I will tell you, for those of you who are not finished, I will still, as strong as encourage you, go get furnished before you start doing these things. Do them when you get to this point. It will just make more sense. And if you go, but I'll have to maintain my code. If maintaining your own code is the problem, then you've got a bigger problem than even writing a compiler. You can't maintain your own code. All right? So there's some important stuff missing from the symbol table. All right? The truth is, what I'm going to ask you to do isn't needed for syntax analysis. That's why I didn't ask you to do it. It's not even needed for semantics, nor is it even needed necessarily for iCode. And if you go, then why are you making us do it? Because you will need it guaranteed before you can do target code. But the reason I'm asking you to do it now is think of software as being like a build sequence for building a house. There's a certain sequence you can build stuff. And if you know anything about houses or you know anything about anything that you build, you can think of, hey, with a house, you build the foundation first and then you build up and put the roof. If you go out and build the roof, the first thing, you could go, well, it's kind of hard to put that on top of the house after you got the house built. You got to go get a big crane and maybe kind of a weird thing. All right, so there's a build sequence to software that makes sense. There's a build sequence to our compiler that makes sense, which are following the phases that were worked out. Not that I worked them out, but I worked out details in it. The things I'm going to give you to do are good for you to do now because you will know the symbol table most intimately when you have finished semantics, all right? But we're going to go back to some extent into syntax analysis and add a couple of things, all right? And it's because right now you know that code really well. The truth is, if you go into iCode and wait till you get to target code, some of the details I'm going to talk to you about will start becoming vague and fuzzy. But again, if you're in syntax analysis, I'm going to encourage you, just keep working to get done, because the truth is, then you're kind of behind schedule. Go get that done. Go get semantics done. And when you get to this point, this will be the point to make those changes too. All right? So let's go look at what they're. All right. Now, this goes back to something I hope y'all can almost repeat off the top of your head. The hardest problem we'll ever solve, oops, dang it, keep losing my pen, is a base address and an offset. For those of you who really figured that out last semester, doing the multi-threaded option is really just truly understanding base address and offset. That's the key to everything in that. All right? What you will really figure out, the key to making everything really work in our compiler. The hardest problems we're going to solve are base address and offset. Now, what will happen is sometimes it's hard to figure out what the base address is. Honestly, I'm trying to explain it to you. Sometimes it's a little harder to figure out what the offset is. Sometimes it's a little harder to figure out each one, but generally one or the other is a little bit harder. So it's not just, here's simply the base, here's the offset, but you can think of just like when we were doing function calls in 4380, the base address is always a register, all right? Now, you have to make sure you compute that correctly, but you get a base address and the offsets just takes us each variable. Okay, it's the same thing. We need base addresses and offsets, all right? What it amounts to is we need to start creating offsets. We can't create base addresses right now because that has to do with runtime, where things get allocated out. And if you don't understand why I'm saying that, I'll tell you, it will make more sense when we get to the code. But just think of, as the analogy, we would know our base address is going to come from a register. But where that register was set to was based on where your VM set. But ahead of time, you can know exactly where they're offset to each variable in a function. Now, we've got more complexity here because we don't just have functions. We've got objects that we're going to allocate, and we got arrays, and we got other things. We need to go figure out some offsets here, all right? And so that's what this is going to do. So we're going to start with a class. Not that you got to start with a class, but in some ways, I don't know, it's a little easier to explain, even though it's newer to you, all right? Now, again, what I'll remind you is you've done stuff very similar to what I'm getting ready to show you right now when you figured out the size of a program in your assembler where we had a count, and we'd say the count starts at 0, and then we'd go through and say, if I stick a label into the symbol table, I go, here is where that label starts. It starts at this address, but that was really going to be, and so you could say that was an offset into memory. If you said memory starts at 0, it works as a base address and offset. And then we would go, how big is this thing? If it was an int, we added 4. If it was a byte, we added 1. If it was an instruction, we added 12. So what I want you to see is you've done this before. It's just different. Don't believe you don't know anything about this. You know a bunch about this. You couldn't even have got your assembler to work, much less your VM, without having done this. All right? So let's go look. Notice I got my offset. Think of it as the same thing. It's my count that I'm explicitly going to call it my offset. So now what I'm describing to you, when you stick these variables into the symbol table, you need to create a new attribute, which you haven't had before. That's what I'm telling you. You haven't done this. Go add this to your symbol table, that each variable is going to have an offset. And so go add that and make it computed. But again, I want you to see, you can do this all in the symbol table. The symbol table is where you're adding every variable for a class, so the offset can be tracked inside the symbol table. And to kind of go for Dana's question is, when you do temporary variables later on during semantics, they will do the same thing. So there will be no different. We will look at this in functions, but we're going to look at it in class. But temporary variables will go through the same process. Why? Because they're just a variable. All right, so we compute their offsets, but I'll show that when we do functions. So think of, when I put age into the symbol table, let's just assume you're on schedule, on task, and you've already done this, then great, then you understand, so you're going to put it in there with an offset of 0, because that is what it's going to be. The offset is going to be, it doesn't tell you where it's going to be allocated on the heap, because our objects will all be on the heap. Remember, we didn't use it in 4380, but we're going to use it now. All right, it's going to be an offset 0. Now, its size is 4. Why? Because it's an int, and that's what we're going to do. We're just going to treat it as an int. What I will let you know is you do not have to change your VM in any way, shape, or form as long as you wrote your VM the way I described to you in 4380. Everything we've been describing will work in it. And if you go, but we don't have bools. Sure we do. We've got the capability to do bools. We got the capability to, you do not have to add anything if you simply finish your assembler and your VM the way I described. All right, so we got an offset of 4. That means my count changes to 4, or essentially my offset, sorry, I want to call it count. All right, so I got a char. Now, what you're going to notice is I am going to add 1 here. Now, one of the things I'll tell you that's a little different, and you'll see it when we get to functions. If you remember, when we dealt with an int in a function, we counted it as taking up 4 bytes. I am not going to make you change that code. We're going to do the same thing. So if you're like, oh, he's changing stuff, no, functions are going to work the same. But I am going to ask you to change your view when you're looking at an instance of a class, essentially an object allocated to heap. When you deal with a character, it is 1 byte long, because that's truly what it is. And if you go, well, why don't we change it with respect to functions? Because I'm not going to make you go do something that, to some extent, you've already made work. And what it's going to allow you to do is literally, for those of you who really made that recursive function work in Project 4, you'll be able to cut and paste that code in and pretty much automatically generate, not the specific function, but the concept of making a function, and you won't have to rewrite your code. But again, that will come when we talk about target code. But you're gonna figure out, you get to reuse code you've written, and then you just turn it into the equivalent of a macro, so we generate it from a compiler. It's part of what helps you get target code done. All right, so we've added 1. You can go, okay, this is going to be pretty simple. I got a 5. So when I add in against gender, make sure you have its offset. So again, when I get to weight, its offset is going to be essentially at 5. We increment by 4, so we keep going. Okay, so now we have got a cat. Now this is a question for the gallery. what is the offset I'm going to add for cat? Oh.
My guess is 4.
The size would be 4. The offset is 9. I think you already put it on there.
Oh, right. Yeah, plus 4.
Yes, what they said.
Size is 4.
But is that's what I'm going to stick in the symbol table?
I don't.
Yeah, because it's going to be a pointer to that object. A pointer to that
Every
method.
single class is the same instance for every single method that executes. I don't think you actually need methods to be calculated with an offset. When you run the method, you go to the subroutine associated with the method.
There you go. Matt's right. What I want you to see is this is the thing I've started alluding to you. This is a lie the compiler writer told you. What you believe when you look at this is that the cat constructor is part of this class. It is not. This is just a construct the way it's written up to make it easier for you to maintain. There are no functions inside of the instances of our classes. And if you go, but isn't there a pointer? No, not to the function. And the reason I'll tell you why it isn't is, even though it looks like you do, when you call a function and you see syntax that looks like this. Now, this might even been how it was described. Is your teacher might have said, you're calling this function like on that class. And the truth is, if that's really the way it was explained to you, I'm sorry, your teacher was lying to you. Now, they might have been lying to you because they thought it was an easier way to explain it, which I would tell you, if I was teaching people in a more introductory class about object-oriented programming, I'd probably say the exact same thing. Now, there's a possibility your teacher didn't know how it works. But the truth is, when you see this, from now and the rest of your life, you ought to begin to look at it as it really means this. And if you go, no way, you're going to figure out way. There is nothing that can do that on a computer, because that doesn't mean anything. All we are doing is we are passing the object in as a parameter. And you're going to figure out which parameter it is, and we're going to have to deal with that later. But you've already seen it. What's its name? We've been talking about it. What's its name when we get into this function f? This. There you go. Somebody said it, but they didn't say it with conviction. But you get it. It's this.
I was trying to be quiet. It was me.
Okay. But it's this. So you've seen it before. It is a passed parameter. It is a known parameter, and we always have it. But it's just passed in. And if you want to go, we're going to push it onto the runtime stack and pass it. All right? So, yeah, I was giving you a red herring and setting you up. I'm not trying to get you to failure, but I wanted to get you to think. But I want you to see. So to some extent, we get to this offset, but there's nothing that is incremented here, because the function itself doesn't take any space in the class. It will take space, just like you did in 43, out there in code space, but that's where it's going to take space. But it doesn't, there's no space allocated for it in the class. Parker, you got a question?
Yes. So what you just described with like functions not being like part of a class, is that
Right.
true for all programming languages?
Yeah. I don't know of anyone that would do it differently, because this works for objects. What you really figure out, it doesn't really make any sense to do it that way. Now,
If you allow time allocation of delegates, then yes. Otherwise, no. Not for methods.
yeah, and what I would say, you could possibly come up with a scenario where you would do it, but you don't need it for object-oriented programming. You might do it if you have some kind of very generic class out there, and you discover what the class is at runtime. But though we won't implement it, I will show you how inheritance and polymorphism is done, and even with polymorphic code, where you can have like a SAR class, and then you can have all these derived SAR classes, something like that. To even resolve, derived classes methods, even that does not put anything in the function or the functions are not put in the instance of the class. It is still, they're completely separate. But I'll show you what has to be added to the class, but it's not the function and stuff.
Awesome.
Alrighty?
Thanks.
Okay? So, yeah, I put this down because I want you to see that's what our offset is set at, but the size is 0, so we end up at the same place. So the cat class still goes into your symbol table just like before, but it doesn't have an offset, all right? Not to it, because it's not part of the class, so it doesn't take any space in the class. All right, so you can see I've got litter. Hopefully everything is starting to make sense now, even though I throw you a curveball, to see if you could get it. And it's like, so we got litter, so what are we going to do? It's +4, it goes at 9. So remember, we got to be counting the whole time, but in this case, the functions don't count as anything. Okay, so we're going to be at 13 here. Hopefully the point is made. You can go, we're at 13, but it's a method, it's a function. It still goes into the symbol table, but it doesn't have an offset, so we don't increment for anything for it. Because sometimes people want to think, oh, but how about these variables? And it's like, these variables aren't in the class, all right? Those variables are in the function, and we're going to deal with that on the next slide, all right? So now we'll come down here, we're still 13. This is going to give you an idea how I suggest everybody implement bool. And the truth is, make it 4. And if you go, it's 4, that means it's an int. Exactly. Make it 4. We're going to use an int. Remember, 4380, we really only had 2 data types. We got an int and a byte. We're using int for this. It'll just make your life easier. All right? So now we're going to come down to an array. All right? It's not a function. Now, I'll kind of ask. And just because Matt asked the last one, I'll see somebody other than Matt, see if you can answer. And I know I probably scared some of you. Its offset is going to be 17 because it's a variable. Can you tell me what's its size? How big
I
are
think
we?
it's 4. I think it's going to be 4 because it has to be a pointer into the heap.
Exactly. Dan is right. That's exactly.
I got the
what
last
it is.
one wrong, so I had a 50-50 chance on this one.
See, you made up for it.
I've been programming for 30 years, and I got that last one wrong. So, this is cool.
But see, it's this whole concept. People say you can't teach an old dog new tricks.
Well,
You
I'm
can
an
learn
old
new tricks,
dog.
and I just
That's a
not doing
different.
it. And I'm sorry, I just called you old. Or
No,
old.
no, that's
Or
a
old
truth.
dog. All combinations of the above. But given we're probably about the same age, I'm basically talking to myself too. Alrighty? So this is what's going to happen. Just like what Dana said, this is the pointer. So we don't have static arrays. Remember, we've talked about this before, is we can assign to essentially the kittens, we could assign, let me just do it here. Imagine if that semicolon wasn't there and we could do a null. All right? In fact, we could set up a static initializer, but I'll tell you, we will talk about static initializers, but it will be much later. Don't worry about it until we get to it, but I will explain static initializers to you because they're kind of funky and different too. And again, static initializers, I'll just tell you, are a lie the compiler writer told you. That's why most people don't think they work the way they do because they look at the code and go, this is how it works. And it's like, no, it's a computer. All right. So one of the things I want you to think of, when you add this to your offset, you're going to get a value. Now, the truth is, this value tells you the size of the instance of a class. You want to store this value, okay? It's the final offset, but think of it's the size of the title class. You want to store this with the cat class as the size of it. And if you go, why? I don't mind telling you. When we allocate a class to the heap, that's going to tell us how big to make it, because that's exactly how big. These offsets tell us how to, if you want to think of index into it, but it's how to go from the base address of where it's at, which later on we'll talk about how we get, but from the base address, how far do I get in to find any one of these things? And based on knowing these sizes, we know what to grab out of it. And again, because I've just been doing Project 1 in 4380, you can think of this all goes back to Project 0, Part 1. even before we did the first project, it's the same hunk of code, it's the same stuff you're going to write to make this work. So you can go, I've already made that work. And it's like, yeah, don't worry about it. You've already got this code to work. All right. So this is what you need to add into your symbol table for classes. So again, just think of when you added in variables, go change it to keep up with their offset. So every single variable ought to have an offset when it's a class. The class itself needs a variable, which is size. All right. So you can say every single, both classes and variables or instance variables have a new attribute. All of them do. And you need to change how you've written the code. But you can probably go, oh my God, that's pretty simple. You know how to do it. And again, keep this offset just in your symbol table because everything is added into the symbol table. It can compute its size. You don't need to add it out in the middle of where you're parsing. Just stick it all inside your symbol table and it'll work. Any questions before I flip to the next thing?
So in the symbol table,
Uh-huh.
every variable in class will need an offset and a size added.
Well, not every variable will need a size. Every variable will end up needing an offset, but right now we're just talking about offsets to instance variables. We're going to go look at functions, which are other kind of variables, but yes, they will need an offset too, but to some extent, it's a little bit different, but it will be called an offset because it's a base address and offset problem. But only the class has a size. Variables don't need a size per se on each variable. You just simply need to know, for each data type, what is the size I use? And that's just some generic concept, but that don't need to necessarily be in your symbol table. That's just something your program will know. Just go, hey, if I'm dealing with an int, it's 4. If I'm dealing with a char, it's 1. If I'm dealing with an array, it's actually 4. If I'm dealing with anything that's a class, do I have anything that's a class here?
Little suggestion here.
Yeah, at least in this example, it didn't. But if we had a private or public, see, notice the access modifier doesn't change anything. But if we had just a cat or a dog or something else, it would literally just be 4 as well. Because this is the same as Danny said. It's just a pointer. It's a pointer pointing at a cat.
Just a thing to clarify.
Uh-huh.
It is still size 4 for a char for a function call, though. Not in the class.
We're going to look at function calls here in just a second, Mike. Matt, sorry, I said Mike. But, yeah, we're going to look at that here in a second. So everybody okay with classes? All right. So function calls, what are we going to do? Now, to really understand what we're doing, you need to think back to our activation records, all right? Because the offset we're computing is part of our activation record, and I need to give you some details on how activation records are going to be built in here versus what we did before. But what I'll tell you is everything you learned before is still valid. We're not going to change anything. And that's what Matt was just asking me. Our character is going to be 4. Yeah, we're going to use that same definition when we're accessing character data in a function. We're still going to use the exact same thing. It just kind of makes all of our code flow, and you don't have to do anything different. And you may think, isn't it going to make it inconsistent? And the truth is, when you're dealing with functions, it's really so different than when you're dealing with classes. It doesn't make it inconsistent in any way to go, one's 1, because literally you'll use an LDB to load the data even when you're going to a function call, and you'll go, all it grabs is 1 character with the data, and you go, it works out. It's really not bad at all. All right. So the thing is that we talked about 4. Now this ought to seem real familiar. Hopefully if you haven't forgot everything from 4380. We've got a return address. Okay, remember we start subtracting -4 because the values are negative. If you treat them all positive, then you've got to turn around and treat them as negative. So the truth is, it's still going to be a base address and an offset, but the offsets are negative. This notion of being negative offsets will come up. And if you don't remember, the base address would always be the frame pointer, but that won't come up until we get to target code. But that's our base address, right? Just as a reminder. So it hadn't changed. So if we look at this, these two are the same because they are. But what you'll notice is we got a this. Remember I said we're going to pass the this in. Now, if you look at this, you might go, I'm kind of confused because you just showed this as a pass parameter. And the truth is, it is a pass parameter. But I'm going to give a hint about something we're going to do to make it consistent. Every single function you can have will allocate space for this parameter, including the main. And if your statement is the main doesn't have a this, you were correct. But we're still going to allocate space for it. And the reason is for consistency. Because when you get your main to work, and this has been proven out, not just in theory, in practice, when you get your main to work, it will be really easy to transition to get the rest of your program to work for method calls, because you will have already worked out the capability to call a function with a this parameter, even if you can't use it. But just think of, you might have a function that passes a parameter called I, and you just don't use it. We're going to have a function that, that has space for this parameter, but you can't even reference it because you can't even use this. So don't go and change your program and go, so inside the main, I can reference this. No, that's an error. You can't find it. Remember, that's a semantic error we talked about. This can only exist inside a class, but we're going to allocate space for it. And that's all it's telling you. We're going to have space for this. So that goes back to something I've described for you before, is if you can remember, this came up a couple of times, I think even last week and even the week before, where I said, this, you don't need a separate symbol for every single member function. Why? Because if it's a member function and you do an I exists on this, you know it exists because you're inside of a member function. Actually, even if you're in a constructor, if you're inside of any function inside a class, it has a this parameter. It will. And the truth is, what you can know, don't need to click on that, is what's going to happen, its offset is always, can't ever change, going to be -8. And so if you want to know what the offset to this is, it can be hard-coded in your program. It will happen later, but you can think of the offset to this will always be -8, so you don't need to go look it up inside of every function. If you ever need to know the offset to this, just immediately return 8, because there's no reason to go look it up. It's just like if you're inside of a class and you're in a function, if you ask for this, the sim ID is this, because it's unique. And the truth is, all we really need to know about it is it's essentially, it's at -8. And then if you go, but what's this data type? It's the class that you're in, so you know everything you ever need to know about this. Now, I hope I didn't lose you, because in all honesty, it's almost so simple, it's just trivial what I explained to you. All right? I'll wait. Okay. Now, in this function, what we've got that you can see is we've got pass parameters. Okay? These are my pass parameters. Now, maybe I should have made it more complex, but I just use all ints. But the truth is, if they were characters or ints, I'm passing them. But the truth is, if you remember, and you're going to see, we got a character down here, we got a bool, and we got a char. What I'll tell you, everything is going to be size 4. Why? Because that's what we did last semester in 4380. So when I allocate space for my pass parameters, just think of it. It's the way you put them into your symbol table, the order you put them into. So now just think of working left to right, and that's really the way you want it to work. Now, technically, you can make it work backwards. I will tell you, my slides used to always show this backwards. And unfortunately, it made a lot of sense to me, and it would make sense to students later, but it was confusing to students. And if you wonder, why did I used to do it backwards? For those of you who have finished semantics, and you put operators on the, you pass You put variables onto the semantic action stack. Then when you pop them off, you can think of you pop them off on reverse order, right? Everybody kind of get it? You're working this way, and then you pop on reverse. That's why I thought of the pass parameters in reverse. I have since changed my slides. If you ever see anything with the variables reversed, I tried to change this all this summer to make it the way most of my students think about it, because most students do think about it in the same order that you see it here. So think of each one of these variables as they're stuck into the symbol table, and again, they're stuck in. Now, you know you're adding them for a function, so I want you to see their offset is to some extent a little bit different because it doesn't start at 0. The entire function starts at 0. But this, if you want to think of, it's like it's hard-coded. You don't need to add a return address into the function. We already know that. Think of it's hard-coded. We already know where the PFP is. It's hard-coded. You don't need that in the symbol table. I know you may go, isn't this inconsistent? And it's like, no. Because you're not going to look up in the KXI code or the I code that you're getting the PFP. That's something purely in assembly code. This, like I say, you'll hard code into the symbol table because you'll look it up. So what it's really telling you, and it'll show you here in a minute, is when you start your offset counter, it needs to start at -12 because these will always be allocated. So instead of starting at 0, think of your offset starts at -12. And then you go from there. All right. So this is how we've done. So we've done all of our pass parameters. Then we come in, we're looking at our local variables. And again, we're going to do it over here, but you can think of here would be our local variables. Oops. And kind of going to Dana's question a minute ago, we're going to have temps. And so I'll show you the temps. Hopefully I haven't forgotten any, but I don't think I have. We're going to have a T1 for this. And if you remember, we've talked about why we generate this in semantics. You're actually starting to see where it's going to go on to the activation record. So we're going to have a T1. Oops. We're going to have a T2 over here, because remember, even though that comes first, this gets evaluated first. We're going to have a T3 for this, and this will have a T4. So we're going to generate all these temporary variables. In actuality, what's going to happen, they're all going to be part of our activation record. So we have to allocate for them. So this is what the activation record will look like for this function. It will be this size. This is where every variable will lay out. This is what I've talked to you about. When you're doing tests, when you're laying stuff out, you don't guess. You lay this thing out just like I've done. Use like an Excel spreadsheet to look at your functions and go, oh my gosh, I know where every variable is. I know what each offset is. I know what their sizes are. My gosh, their sizes are easy. They're all -4. But you know where everything is. Then you can check that everything get laid out in the symbol table exactly the way you expect. All right? So test this. Make sure it really works. So now, this is the part I've already explained to you. Because every function starts
Can I
with
ask a question before we go on?
Yeah, go ahead.
That this.x, that says kind of to me that you have a local variable called x. That's an int.
Well, if you're saying this dot x, this kind of makes us jump forward, but I will answer it.
Well, but when you've got it there, right down, below the first ellipsis.
Uh-huh.
Where is that x? What x are you referring to there? Because I don't see it declared.
No, it's not. Because what that says to do, I'll explain. Imagine here, what we're going to have is a pointer pointing out to the heap, and there's an object out there.
Okay, so this is a method of a cat that has an x inside of it.
Yeah.
Public x.
Yeah.
Okay, I missed that.
Yeah, and just for everybody else, in case they're not getting it, think of, we've got an x in here that occurs at some offset. And that's what we computed over in the class. So if I've got an x, and literally what it will be is, remember, base address plus offset. That is my base address. That's my offset to this. I will add these two together. This T1 that I had written here, we're going to stick that base address and offset in T1. right there. I mean, this is getting all the way down to Target, but that's what we're going to do. Okay? We're going to have that sitting here. Then when we want to go add X, what do? We grab this and we do register indirect address, and it points us right there at that variable. Anybody not get it? Instead of me asking, does everybody get it? Because I can't see your faces to see if you do. But you get it, Dana?
Yep. Yeah, I got it.
Alrighty. So yeah, then you can think of the only thing we have that isn't a method of a class, or to some extent a function in a class, is the main. And the truth is, we won't be able to reference this if we put it in the main, because that should come up and say variable not defined, because it's not defined in the main, even though we will allocate space for it. So its activation record, if this was the main, we can't pass parameters in, so it would still be different. But if we could pass parameters in there and call this the main, it would literally look exactly the same. We would allocate space just like that, but we'd just make it where you can't reference it. And so we'd go, we've got empty space, but it makes all of our activation records. So realistically, you only got to write one hunk of code to deal with building activation, and that's what you're going to figure out here. You only got one hunk of code that does it, and it does it the same for everything. Just this on the main will literally be set to null. Literally, not even conceptually, we'll set it to null. All right, so now let's kind of go through and see what's going to happen. Okay, here's already what I told you. We're going to be starting at 12 because this is already going to be a base for everything, even the main. All right. Again, my total size, notice, is 56. I should know the size of my function. All right. So my function has a total size, but it's not really that I got to know the size of my function. I need to know the size of my function to compute something else. And what it really amounts to is these locals and temps. And again, I'm going to try and get you to remember back to 4380. All right. So we're dealing with some target code-ish kind of things, but it will help you if you go set up these. And so I'm going to go ahead and explain it, though I'll explain it again. If you remember, when we went into a function, the first thing we did was allocate space for the locals and temps, because only the passed parameters were on the activation record in this information down here. So technically, think what we really got going on is the same thing that we had last semester. We've got this base information here, which we had last semester. You go, that's the same. We've got passed parameters, which are these. We just happen to know we're doing this sneaky thing that we're always going to pass to this. So we act like it's different, but it's a passed parameter. We're just always going to pass to this. Even if it doesn't look like we are. We're always going to look like we're going to pass to this. So we got our passed parameters. Our locals and temps we allocated space for when we were in the function. That's why you were supposed to do the first thing you went into a function. If you said, I didn't do that, I did it a different way, shame on you. This doesn't make sense to you now. You got it wrong. It was supposed to do an add immediate when you went in there and allocate space for the locals and temps. Now, and if you go, you set this up for compilers, just like, no, I always did 4380 that way. When we came to the compiler class, it just worked really well. All right. So literally, we need to figure out what this space is for locals and temps. All right. And to some extent, it's just a little bit of multiplication that you need to do. Again, you can do it in your symbol table, is if you'll go and figure out how big your total function is, the total size of it, and then go figure out how many passed parameters that you had. You know they're each 4. Do a little bit of math and figure out what the locals plus the temps are. And in all honesty, you can either figure this out on the fly or you can store it for the function because you're going to need it. But it doesn't matter if you compute it later or compute it and store it, because we're not going to look it up multiple times. And you're going to be able to compute it, so you can do it however you want, but you've got to have a way of knowing what your locals plus your temps, what that size is, because when we get into the function, you need to allocate space for it. And do not get ridiculous and go, I'm not going to figure this out to make the project easier. I'm just going to allocate 1,000 bytes to make it work. If we notice you do this, we'll reject your project, but also it's just such a horrendous idea. You should be ashamed if you even think of it. Don't do it. All right, it's a ridiculous ideal. Plus, I've had students do this ridiculous ideal and then run out of space and can't get their programs big enough because we start doing recursive function calls and they almost can't get memory big enough. And it's like, I know this fits in anybody's program, and what they do is they just keep making this space bigger and bigger. But generally, when people do this, they don't want to go figure out anything, and so they're generally wiping over memory, and so they generally have all kinds of problems because they don't want to go figure anything out. They think taking what they think is a shortcut is helping them, and it is going, I'm trying not to understand how my functions are laid out by just going, I'll allocate enough space, it won't make any difference. That means when your variables break, you don't even know where they're supposed to be. So don't do it. Don't do it. It doesn't help anybody. I've never seen it help. It just sets you up for failure in all kinds of places.
Dr. Wellborn.
Uh-huh.
So as part of this iCode generation, figuring out what the temporary variables will be?
Yeah, you can think of that's kind of what Dana's question was, and what we've shown is every time we do something like a mathematical expression, we generate a temporary variable. Every time we did something with like a dot, we generated a temporary variable.
Right. Okay.
You know, so
But we'll
yes,
figure those out during the semantic part of the program, not during the iCode.
Right, but I thought you said semantics, didn't you, Parker?
I think I said iCode, but yeah,
Oh,
no,
okay.
semantic, I remember
I
that.
heard the wrong thing. So no, you've already figured it out. And figuring out these offsets you need to do before you start iCode. It's not part of iCode. You go back to syntax analysis and add this in. And you can think when you add in the temporary variables, it'll figure out. So it's really when you add a variable into the symbol table, make the symbol table figure it out, regardless of what pass you're in. And that's really what it should do, is it should simply say, if I add a variable into the symbol table, figure out what its offset is. And so you can think of, inside of functions, you will know all of the space that you have for everything except the temps, but the temps will all be created during semantics. But if you think of how do you keep up with your, sorry, I've got too many things written here. And again, it's the same thing. The track, when you're adding in variables during semantics, put it into your symbol table. You can think of, you should be tracking the total size of your function. The total size of your function at the time that we call it in semantics, to put in 40, put in 40, to put in T1 is 40. So literally, if you know the size of your function, that is always what the next offset is. So think of, track the size inside of the function. When you add a new variable to the function, it just grabs that total size, sticks it on as the offset, increments it, and sticks it back into the function. Hopefully you're following, but it's just track it in the symbol table, because it is. And so don't think of creating some special little variable for it, and then you go, but I lost it. It's the size of the function, so track it in the function. And so you always know what you can think by default when you create a function, create the size as minus 12, because that's the size of it the minute the function was created. All right, because we're always going to have these things on it. All right, but start adding this back into your symbol table.
Sounds good, thanks.
All right. So so everything we've been talking about up to this point is not iCode, but it's things you're going to do to your symbol table. All right. So actually, we are going to go kind of the whole time. But notice it's a super, like I said, it's a super general introduction to iCode, because we really haven't talked about iCode. We've talked about your symbol table and change. You're going to go back. So the super introduction to iCode is iCode looks a lot like assembly code. In fact, that's what it's meant to be, but it's a simpler version of it. Now, I will tell you, the iCode I have come up with is unlike anything I've ever seen anybody else do. Now, I can't say I've seen a ton of things, but I've seen the compiler books I have, the iCode they use, and we ain't going to use that. It's too much. It's it's not intermediate enough in my opinion. So I came up with my own. I will tell you, when I finished doing some iterations on this, and the iteration I'll talk about later on, that was the last iteration I did to it, because I pretty much came out with this first semester that I did. It was kind of based on something I did in school, but I found a correction to make. It's so simple. I have no doubt, based on the speed of some of y'all are going, I have had students almost every year finish iCode in a day. And I mean a day. Now, I have never had a student finish iCode in a day who says, I am behind schedule and I'm going to go finish it in a day. That doesn't happen. I've had students sit down and go, I understand what he's saying to do. Sit down and start working on it and go, oh my God, I do understand this. Now, I'm not saying it's 3 hours. I'm going, it's like a work day, 8-ish hours or more, but I've had students finish it in a day. Most students can finish iCode like in a weekend. Some of you will need more, so you will get 3 weeks to do iCode, but don't look at this as a way to slip your schedule more. Look at this. I have built in a slip for you, all right? If you get no more than 2 weeks behind, you will catch back up potentially here. Or you can go, you won't slip even more because this can be done. But I'm telling you, some people can't get it done this fast. But I have had people sit down in a single long day and finish this. And based on the speed of a couple of students in the class, I would go, I pretty much expect it. And so for those of you who think you understand what I'm talking about and want to go fast, what I'll encourage you to do, work on your other classes, test the other parts of your code, but wait till I get through explain enough of iCode that you can sit down, because the truth is, even if you don't work on it, so I'm not telling you to procrastinate, I'm telling you work on another piece of your compiler, because if you will, let's call it procrastinate, because maybe that's what it is, but work on another piece of your compiler. You let me get explained enough of this, you will potentially sit down in one afternoon and finish it all. So let me get through it. Don't rush to get to it until you make sure you understand what I'm showing you, because this is not like semantics. It is not meant to be 3 weeks worth of work. It is, we're going back the other way. I'm giving you 3 weeks to finish something that quite a few will finish in a weekend. All right. So it is meant to be simple, or if you want to call it simplified assembly code. Now, some of the things we're going to do, so it is an incremental step. So if you think of why do we do it? Why don't we directly go from KXI to 4380 assembly? If you want to think of it as, it's like, oops, dang it, just keep messing up. But it's like a great big jump. And great big jumps aren't good in software development. You want to do incremental design development. So what are we doing? I've created intermediate code, and I didn't design the concept of intermediate code. I designed this intermediate code. Intermediate code is a concept to go split the difference and get part way. And then take this step. And just think of it as you were taking steps. If I told you, I want you to cover 8 feet in a single bound, you might go, I can't jump 8 feet. And if I told you, well, you can take 2 steps, you'd go, well, that's easier. That's 2 big steps. Technically, this isn't that bad. And another thing I will tell you is, well, iCode can be easy. We have also seen, and I'm saying we, I'm talking about Ethan here, but also other students who finish this class. Many students will find converting iCode to target code. Most students find this the most scary, frightening thing to think of doing. Most students will find in practice, it is one of the easiest things I've asked you to do all semester long. Now, testing it can be harder, and we'll talk more about why it's harder, but it really just has to do with, I don't bring it up again, but it's something I showed you last time. You've got so many moving parts, from the KXI file you write to every phase of your compiler in the symbol table, everything in there, to the assembly code you generate, to your assembler and your VM, and when you go looking for a bug, it could be any place, including you didn't write the program you thought you did, which I explained to you last week. And so there's a lot of moving parts. But actually, to generate the code, a lot of students have told me they believe this is the easiest part of the class. And I have talked to professors who've taught compilers. Most of them say code generation is the hardest part, and the truth is, I believe it's become easier for my students for a combination of reasons. One, I give you all those semantic actions. The way I lay out the semantic actions will relate directly to the I code we produce. The kind of I code we produce is different than I've seen anybody else do. It is easier. It's then easier to convert that into target code. So I'm not trying to tell you, look at what I've done for you. I'm trying to tell you, don't get psyched out that we're getting to what some people think is the hardest part, because for you, if you can just get through semantics, all right? If you can just get through this thing that I've talked to you about, that is this huge hump of a curve. Work hard now to get this done. Work hard now to get this thing done, because if you will get to semantics, you have reached the peak. The class will start getting easier from here on out. Now, testing can get harder, but you can almost go, for those of you who've done some testing with, you can't really test a lot. You know, you can run some simple tests, but it's like, oh, you're going to really run a program. You're going to check syntax, semantics, I code, target code, run it in your VM. You're going to go, everything gets tested. It's a great big integration process. All right. So again, it's just high-level statements. What keeps it high level is we will have no registers. All right. You might go, how do you make assembly code without registers? Okay, promise you, I did it. You'll see. We have no registers and we have no addresses. And that's what keeps it similar. But our instructions will still look like assembly code. All right? Now, the key is, because we have a symbol table, we're going to use those SIM-IDs out of the symbol table to reference things in the symbol table. This does not execute ever. It's just saying what happens. Because we're running out of time, I'm going to kind of jump through this and show you. So here's just what I told you. We're going to have no registers, no addresses. All right? You're never going to reference a symbol in the symbol table directly with the SIM ID. But let me show you what it might look like. All right? So if we had code that looked like this is a little snippet. The I code we generate would look something like this. Notice it's a multiply. If you can look at this, you're going to go, that multiply is done first. Then that divide of these two things is done. And then we're going to add. And you'll see there's temporary variables. I should have written with the temporary variables on it. In fact, let me go back and write it that way so you can see it a little more easily. Is this multiplication is going to be done first. And you could think of, I'll use the same ones below. That could be like temporary variable T1. Then we're going to do a division using these two. And that would generate a temporary variable T2. And then we're going to do this addition, and that generates a value T3. And you generate those temporary variables during semantics, right? I asked you to do them. So when you get to it, do them. So the way our I code is going to look, it would be multiply the SIM ID for B, the SIM ID for C, and the result is going to go into T1. Then do a division of T1 and the SIM ID of D, and generate a value of T2, and then you do the addition of the SIM ID of A with T2 and T3. And if you go, I don't understand how I'm going to keep up with T2 and T3. If your semantic works, you've already kept up with it. Don't worry about it. I'll explain later. All right? I'm always trying to get you to understand what it's going to look like. Now, normally when I write it, particularly if I write it by hand, but in all honesty, every place else, you're going to see it look like this. I'm just going to write, and you're going to go, that's the lexeme. You said don't do it. I will always write the lexeme so the example makes sense and it isn't longer. But it is never, ever actually the lexeme. It is always the SIM ID. All right? So think of that as convention for getting the point across to you what we're doing, but it is always going to be the SIM ID, because when you did your I exist or your R exist or any of these other things, you can go, that's why I'm so adamant. You have temporary variables and SIM IDs. It makes this stuff flow out. And if you think of, Ethan was talking to you about this last week, is talking about how I code and target code will just flow out of your semantics. I promise you it does, but you got to get your semantics done. And you got to get them to work right. Because if they halfway work, then your I code will only halfway work. And that means your target code will only halfway work. And that is an incredibly hard bug to track down if it just halfway works. All right? So I'm going to stop here and see if I've got questions, at least for a few minutes, because the quad is just the way the I code is laid out. But I'll plan on coming back to this. Do I got some questions? Because y'all been almost amazingly quiet. No. Okay, this seems spooky. So if I gave you a test right now and asked you about I code, everybody could do it. Pop quiz. No pop quizzes, promise. Alrighty. Hey, Amon, you got a question? I saw Matt did too, but go ahead,
I was just saying that.
Oh, wait a minute. It's Ammon?
Yeah, Ammon. I was just gonna say that it generally takes a while for it to gestate. So as we run into doing this, that's probably when we'll have our questions.
I do understand that, but hopefully what you got is kind of an intuitive idea of what this is, or even what it's not. And I'll kind of reference, like, Parker sometimes asks questions like, are we doing this thing? I don't see it as he's always confused, and I hope you don't either. What I see Parker's doing, he's just reaffirming what he believes and making sure I say the same thing back to him. So I go, I hope you kind of have an intuitive understanding of it, because we're going to start building on this. And so I'll say, yes, you got other things to code on, but make sure you kind of understand some of these intuitive things. But anybody got any questions about adding offsets or what we're doing over there? Because like I say, I'm going to encourage again, don't stop what you're doing unless you are to the point of starting I code. All right? So if you go, I'm starting semantics, but I'm going to go back and fix this. Don't. Realistically, you need to get syntax to work. You need to get semantics to work, and you need to be testing that with people before you ever start offsets. And it will become more understandable why, but it is important to get that tested, because I will tell you honestly, the most common bugs for people to have, why they will have so many bugs they can't even attempt to pass on, is not their target code or their intermediate code is so messed up. It is their syntax and semantics are so messed up, they figure out they have messed those up. They didn't test with anybody. They can't even attempt to start a pass off because they start finally testing with people and they have deferred it till the end of the semester. They really deferred almost testing, but they certainly deferred testing with anybody. And then they get in and start really testing, and their syntax, they didn't follow the grammar. Their semantics is completely messed up. And as I said, if your syntax or semantics are messed up, you can't do I code and you can't do target code. So there's no reason to rush to start adding offsets. Get your syntax and semantics really to work. And like I said, then you've got a place to go from there. Anybody got anything? Matt, you got a question?
No, I literally just said boo because you said we're so quiet it's spooky.
Well, there you go. And think, Halloween is coming up. So, I mean, it's well away, but Halloween is coming. So it's very appropriate. And in fact, Matt's picture kind of looks like Halloween.
It's from an ancient video game that's almost 2 decades old.
I kind of figured it was a video game. So no questions, no comments.
Matt, I'm so old, I think that a game 20 years old is not that old at all.
It's a young whippersnapper.
That's right.
Well, y'all have to remember, not to be mean, but probably me and Dana have been in the computing field longer than probably almost anybody else in this class has been alive on this earth. So
I consider game old if the hardware it came out on isn't being manufactured anymore. It's a very loose predicate, but I think an apt one.
I will tell you, I had a student one year. He took advanced architecture from me, and then he took a computer graphics from me. He was interested in really old games, like the original Wolfenstein, which somebody might know, but like the original Wolfenstein. Using what we learned in 4380, he redesigned a virtual machine for the architecture for Wolfenstein. turned out he shouldn't have been able to find it because it was put out on the internet, but there was the executable code, not the source code, for Wolfenstein. He didn't have all the graphics finished up, but he could run essentially certain cartridge games and other things because he's found the executable code for him. He was going to build a company around this and start running these old games, and then he found out that the company found out this stuff was out on the internet and they had copyright license or something around these things that you couldn't do what he wanted to build a company for. But he actually showed me, I mean, it had really primitive graphics, but he was running some really old games on a virtual machine. The problem was his virtual machine still ran so much faster than that old hardware code. Like the games you were playing, like the little stick figures or what he would have were playing so quick. And I don't know if everybody's ever seen it. When people first ported like the Pong game, it would play so fast you couldn't play Pong. I think it was like playing tennis, but the ball was moving so quick you almost couldn't see it because the processor speed was just so fast. So they literally had to go add weights. Now, what was that?
The update speed was linked to your CPU speed, so the faster your CPU went, the faster the game updated.
You're going to say because they were running as fast as they could just to make the Pong game work. And then when you're running literally 1,000 times faster, you can go, that ball was like 1,000 times or even more. And it's like, oh, that ball would whip across the screen to the point you'd go, I couldn't even try and move the cursor. So, yeah, they added lots of weights. And basically, they wasted a lot of time because the game was so simple, it just wouldn't do hardly anything. But we're all finished. Anybody's welcome to stay if you want to talk old games, football,
part of
another
chewing the fat thing.
Yeah.
That student that made you called it the VM so that it can play the game. Those are actually well known amongst gamers. We tend to call them emulators. There's emulators for almost every old system out there. The way the copyright law ends up effectively falling, if you owned a copy of the game and you owned a copy of the hardware, gray area, maybe you don't get in trouble if you get the emulator and you play the game, and if you can just show that you have the